everyone. We're at the Arizona State University Solar Power Lab, and I am with Dr. Bowden, who is the co-director of this facility. And I want to know, how are solar panels made? What are the components?
Okay, so solar panels are made out of silicon. This is an example of a silicon wafer. It doesn't look like much, but it's one of the purest crystals you can get. These are made in large ingots, about 1 or 2 meters long. It's just made from quartz, which is a rock. And we then take these wafers and we then have to take them to something that'll convert into electricity. It comes doped in a way which we call P-type. And what we need to do is put another contact on it so it becomes N-type, a little bit like a battery. So there's a positive and a negative terminal. So to put the negative terminal on it, we use a furnace over here, which is a phosphorus diffusion furnace, and what it does is it makes small amounts of phosphorus go into the surface of the silicon and creates an N-type terminal. So at that point we have something which is called a diode. So it's pretty much like in any electronics, a diode. It's just a very large flat diode that's optimized to get light. But we can do a little bit better. So what we then do is we have a problem that if we had our straight silicon, it would be quite reflective like this. But what we've found is if we can put on an anti-reflection coating, which turns the solar this pretty blue color.
Oh,
and
wow.
The pretty blue color, it turns out, is just the optimal thickness and optimal wavelength range to get most of the light into the solar cell. So at this stage, we've got lots of light coming into the solar cell. We've got a way of making a positive and negative terminal. But what we need is a way of getting the electricity out. And to do that, we use a very simple process, much like you might make a t-shirt, with screen printing. So the screen printing process has been around for quite a while, and it's quite popular because it's so simple and easy to do.
So you just
wipe a metal paste down through the screen and it comes out onto our solar cell, and finally we end up with a solar cell that looks a little bit like this. So on the front we've designed it so it's a little bit like a leaf. You have these little veins, or in our case wires, which direct the electricity to the bigger stem areas, which we call bus bars, and we can connect lots of these solar cells together to power your cabin or your house, and yeah, away we go. We've now got our solar cell.
So this side is the solar cell, and then on the back?
On the back, for these particular ones, it only gets light from one side. So these might be the type you might put on your roof.
Okay.
However, we can do a little bit more. We can actually make a bifacial solar cell. And so if you look at this one, it's a more advanced version of the other one. Not only does it take light from both sides, it also has much finer wires, so you can't really see them on this particular wafer unless you look really carefully. But this could be designed for, say, a car parking area where you might have a shade structure. You can take the light directly from the sun, and also the light that gets reflected up from the ground. And so this can produce another 20% more electricity. This is one of the ways that we're making solar cells even cheaper and more affordable for everyone.
Wow, that's really fantastic. Thank you for sharing that.
Thank you very much.
I also wanted to ask you, now that we have our solar panel, how do we get electricity from it?
Right. So in order to convert the sunlight to electricity, what happens is a photon comes in, it strikes the silicon crystal and creates an electron, a highly energetic electron. If we don't do anything with it, it'll just release that energy as heat. But because we designed our solar cell with an N and P region, we can direct the electrons to the N region. They'll go into the external circuit through our load, maybe powering our house, and then come back to the solar cell.
So the sunlight comes in and it strikes here, and when it strikes this, it releases an electron.
Yes.
And then we direct where that electron goes.
That's right. So it directs where the electron goes. And the tricky part is, how do we direct that electron in the most efficient way possible? So when we first started making solar cells, they're only a couple of percent efficient. But now most solar cells are over 20% efficient. So you can buy ones for your house which are over 20%. And we think that we can get much higher than that. Eventually, we think we can get to 80%, but that's quite a way off.
Wow, that's really great. Thank you for sharing that with us today.
Thank you very much.